Hello, Internet, and thank you very much for tuning into the cloudnative.fm podcast. And today I'm talking about one of my favorite CNCF project, that is Kyverno. So let me introduce Kyverno, what Kyverno is. Kyverno is a policy engine designed for Kubernetes. With Kyverno, policies are managed as Kubernetes resources, and no new language is required to write policies. This allows using familiar tools such as kubectl, Git, and Customize to manage policies. Kyverno policies can validate, mutate, and generate Kubernetes resources, and the Kyverno CLI can be used to test policies and validate resources as part of CI/CD's pipeline. And today I'm really happy that I am joined by one of the core maintainers of the Kyverno project, shooting Zhao and Jim Bugwadia, the co-founder of the project. Thank you very much for joining on the show. So I'm going to the shooting. So let's introduce yourself to our audience today.
Thank you, Sam. Thanks for the invite. So hello, everyone. This is Shooting Zhao. I'm the one of the Kyverno maintainer, contributing to all phases of Kyverno, and currently I'm leading the development of the releases for Kyverno. And we, just about to release Kyverno 1.8. And in today's show, we're gonna showcase some of the new things that will be coming in this new release.
Yeah, and hi everyone. I'm Jim Bugwadia.
Thank you. And now it's time to.
Thanks, I am. Thanks for having us back again on the show. Really excited to show you a little bit of the new features, things coming up in 1.8, and we can also talk about our journey since the last time we spoke.
Yes, absolutely, absolutely. So I would definitely want to see some of the cool demos today on the show. But can we try to understand, because all this policy engine, I think, is started from PSP. And can you tell us about how Kyverno is started, what the limitation you see in the PSP, and is finally deprecating? When we last time met, we are prepared for the deprecation, but as of today, it's removing, and the PSA is I think replacing it. So can we talk about today for just a little introduction about PSP and how Kyverno is be joining this journey of being a policy engine?
Sure. Yeah, I can provide a little bit of background and context, and then I think Shooting is the expert to dive into pod security and also talk about pod security admission and what we're doing in Kyverno to support that, right? So obviously, as a lot of us may already know, uh, Kubernetes, one of the most powerful features or aspects of Kubernetes is the declarative configuration management aspect, right? Which in Kubernetes, everything works internally as controllers. So there's a control loop, and as a user, you specify the desired state, and these controllers work hard on your behalf to make the actual state match with the desired state, right? But what that also means is there's gobs and gobs of configuration across like concerns for security, operations, developers, etc. Right? And that's one of the reasons why folks who are new to Kubernetes may say, "Oh my God, Kubernetes is complex. Just to bring up an app, I have to do all of this." But there's a reason for each line of configuration, right? If you don't put that in Kubernetes, then you're stuck with some opinionated solution which cannot be changed, which is not extensible. So those are the trade-offs, that are considered even in the design of Kubernetes itself. Now, moving to policies, Kubernetes has built-in policy objects like network policies. It had pod security policies, things like that. And the whole idea, like within configuration management, policy is a way to, to be able to restrict, to manage, to control configurations a little bit better, right? So that is something that, in Kubernetes was already there from the beginning. And it continues to kind of, I'm sure as Kubernetes became extensible, there'll be more, kind of ways to manage things through policies. So, kind of in a nutshell, policies have almost become, if you're managing Kubernetes at scale, if you're putting Kubernetes into production, policies are a must have, right? You're going to need that to be able to control and put the right guardrails for your development teams, etc. Pod security policies are special because, of course, the basic unit of deployment operations in Kubernetes is a pod, and to manage pods, the pod security, the concept of a pod security policy was introduced, right? But what the challenges that the community saw with pod security was it's hard to do something that appeals to everybody, but it's still secure by default, just because there's so many variations of configurations, so many different things that can be done, right? So that's where like the attempt to have pod security in Kubernetes built in, it did not quite work out, as originally planned. It was hard to configure, hard to manage at scale, and really there was a kind of trade-off between new features being developed versus having something which just could not be extended or would not appeal to every user, right? So that's where the community, SIGAuth and SIG Security, they led the charter for coming up with pod security admission, which is slightly does slightly less than the PSP, but is very important to understand and enable by default on your clusters. And I'll hand off to Shooting to describe what pod security admission does and how Kyverno helps with managing that.
Yes,
Sure.
shooting, go ahead.
Yeah, I just want to ask if there's any questions regarding, what Jim just said. But, Jim talked about the PSAP. Then I'm going to dive deep into how pod security emission can be configured in your cluster, how you use PSS to enforce the pod security aspects, for all the pods and as well as workloads. And then we're going to show something that, added recently to Kyverno, the integration of Kyverno with pod security emission, and how you can use that in your cluster to enforce some of the best practices to your pods as well as workloads. Right. So as you know, pod security policy has been completely removed from Kubernetes 1.25. And as a replacement, Kubernetes has introduced a mission controller to examine all the pod security. Just a little bit context of the pod security standards. It defines three different sets of controls to cover the security, say the pod security emission, the PSS, and to apply all the checks to your incoming pods, right? So this is enabled by default in Kyverno 1. In Kubernetes 1.25. It's an out-of-box tool with nothing to install, nothing to configure. All you need to do is, simply assign a label to one or multiple namespaces, and then you're good to go, right? So this is pretty straightforward yet powerful because it provides an instant solution for security compliance of your running cluster, right? So if you have gone through your, let's say, in a single, this is enabled for that namespace. All the checks at the configured level, either the baseline or the restricted level, PSA gonna apply all the checks to the pods within that namespace. There is no way for you to make exceptions, no way for fine and grained control. Let's say if you have application configured in the Blueprint or PSS controls, but there's one single exception. How are you gonna do that? You either downgrade like your namespace configuration for the PSS, or you upgrade PSS track, or you create a new namespace and install the single workloads into that namespace. But is you barely use the standalone function clusters, right? Think almost 90 or 95% of the workload pods are wrapped up in the workloads, and you schedule those. You install those applications into the pod as the pod controller to the namespaces. And both PSA or the PS, so here provide as well as apply the PSS tracks to the workloads resources. We're gonna show that in the live demo today. So let me share my screen for real quick.
Hey, shooting. Also, your audio is a bit choppy, so there might be
We're gonna
some
go
bandwidth issues.
deep into the demo. Screen. Turn off the
Yes, we can.
camera, and I'm showing the pod security standards page now. If you can share. Okay. All right. So as I mentioned earlier, the pod security standards defines these three different level of controls, right? They're at privilege level, baseline level, and restricted level. And at each level, you can define different controls, specify different controls for a namespace, and it'll PSA will apply these checks to the incoming. Example, say privilege container. This is at the baseline level check. So containers, the PSA will examine this control false because the allowed value is either set to false or nil, right? So if you have a pod running in privilege mode, obviously the PSA will block the pod creation, right? To level, which is so called as, so this track will check run. We have to this set the run as non-root to true or leave it empty. Otherwise, again, the PSA will
So Jim, I got some yeah, shooting has some issues while hearing you guys. So can you continue the demo or the other PSA part?
Yeah, let me just quickly, I think some of that might have been lost in the choppiness, so I can just quickly explain what shooting was about to show. So I think, as she mentioned, with pod security admission, now there's a built-in admission controller. You do have to, by the way, configure this through a file in the control plane. So it may be until the managed cloud service providers, like managed Kubernetes providers, provide support for that. It may not be possible to always configure if you don't have access to some of these control plane settings, right? But the idea is that with pod security admission, you can specify now at a root level or at a namespace level through labels the desired level of pod security that you want for the namespace. So that's where, with the link that you also shared, you will be able to then do things like say that for this namespace you want baseline, or maybe other names, or all namespaces you configure baseline, and then you can configure more policies as required for others, right? So that's kind of the basic idea. And with the policies itself, Let me kind of quickly share, and I'll explain, what Kyverno can do. Um, the one other thing that Shooting mentioned, which is very interesting, is if you are using PSA, because it is enabled at a namespace level, you cannot do some fine grained checks, right? So you cannot say that within this namespace, there's one, pod which I want to allow certain capabilities, or I want to allow that pod to run as root, but other pods I want to restrict, right? So the reason why that was chosen is, if you kind of think about from a Kubernetes security perspective, the pods are the namespace is the security boundary, right? So if a namespace doesn't provide that level of security, then basically you're not going to be able to kind of control access on that, right? So because think of the one challenge that is important to understand is, if you allow a workload to be run in a namespace, it has access to all secrets and all service accounts and everything in that namespace, unless you're using a policy controller like Kyverno, or other policy controllers like OPA Gatekeeper, to do fine-grained access, right? And saying that only this image can access this particular service account, or only this image can access other things. So that is highly recommended if you're putting multiple things in the same namespace, or you have to move to a very fine-grained kind of micro-segmented sort of approach to namespaces itself. So that's the trade-off when using PSA. And what Shooting can show, and I see Shooting just joined back. So she was about
That,
to show. Are you able to hear us now, Shooting, or?
yes, I can hear you.
Okay, great. Yeah, so I think she was about to just show the demo of how Kyverno can integrate with PSA and provide that fine-grained control on top with a new policy that we have introduced.
Yes,
Right.
Shooting,
So
can you
let
share
me
his?
quickly reshare my screen. Sorry about that. I just lost the connection. It's just so the connection is poor. So let me reshare my screen. And I'm not sure if I have covered the security standards, like the privilege and running as non-root controls. But I'm gonna, briefly talk about that again. So, the pod security standards are defined at three different levels, and one of the restricted check is to check validate if your pod is running as non-root. So here, simply this control defines the restricted fields that you cannot have, like the run as non-root security context either at the pod level or the container level, to be set to false. The only allowed value is true. And similarly, for the privileged settings, you can only set the privilege. This is for the baseline check, by the way. You can only set the privileged security context to false or leave it undefined so that your pods can be admitted to your cluster successfully. So let me switch to my terminal, and I'm just about to show you. Hey, Sam, are you talking about something?
No, 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 no. I'm not talking about.
Okay. So I'm just about to show you how you can enable the PSA for a certain namespace. And by the way, all the demo manifests today are available on Kyverno GitHub demos repo. You can access all the manifests and test it and play around with it locally. So now let me create a new namespace. And then, as I mentioned earlier, all you need to do is to label the namespace with, the first one is to enforce the security standards at with version 1.23. And then I'm going to enforce this namespace at baseline level, right? So let's label the namespace, and then just to simply test that, I'm gonna run a privilege pod. Just, I just show you right now, just now, that you cannot have the pod set to privilege if you have the baseline policy enabled for your namespace, right? So let's copy this command and run it. So you'll see the immediate response from kubectl command say that your privilege pod is forbidden because you're violating one of the baseline checks, that you cannot have the privilege set to true. And next, I'm gonna show you, how Kyverno comes into play, right? Because if you want to make any exceptions with PSA, there is really no way to do that. And let's say if you want to enable this namespace at the restricted level, once you apply that label to the namespace, all your workloads or the pods have to be comply with all the checks defined at restricted level. But with Kyverno, you are able to apply all the restricted checks to the single namespace, and you can do some exceptions for the selected, either the image, the pod's name, by the pod's name, or some other filters, to exempt from one or multiple controls. So here, this is a Kyverno policy, and I'm gonna, read you through this. What does this policy do? Here I have a Kyverno cluster policy, which is to exempt the run as non-root check. And this policy applies to all pods for this namespace, baseline namespace. But I'm gonna enforce all the restricted level PSS checks to this baseline namespace while I'm excluding the pods running this image for this particular control running as non-root. That is to say, if you have a pod is about to schedule to this baseline namespace, I'm gonna apply all the restricted checks. But if your pod is running as root with this image, then Kyverno will allow that pod creation. So let's go back to the terminal and apply this policy to the cluster. We're gonna see how that will enforce the pods that either comply or doesn't comply with the policy. So first, let's create the policy to the cluster. Okay, I'm not in the right folder. Let's do it in demos, pod security admission, just to check I'm still here. Okay, so let's apply this command, kubectl apply, and then you do kubectl get cluster policy or cpol. You'll see there is a single cluster policy created into the cluster. And then let's run some pod, like let's run a pod that actually, is configured with running this image, which is defined in the policy, and it has the run as non-root set to false. And as I showed earlier, the run as the run as non-root for restricted check, it has to be set to true if you want your pod to be admitted to the cluster. And here, since I'm setting to false, obviously, if you have the namespace enforced at the restricted level, this pod creation will be blocked. But with Kyverno policy installed, we can still apply all the restricted checks, but you're able to do the exemption for this single container running the Nginx image. So what I'm going to do here is I'm going to create this pod into the baseline namespace, and here I'm doing a server-side dry run, and here is the result that returned, right? So this pod is allowed to be created. And let's look at some bad pod example. Let's say if I have all the same configuration, but here I change the image from Nginx 1.23 Alpine to just Nginx. And let's apply that pod to the cluster. And of course, we're going to see that pod will be blocked by Kyverno because Kyverno internally applies the restricted check to this baseline namespace, right? So let's do this apply pod forbidden. And then you will see the immediate response back from the terminal saying that, okay, Kyverno webhook blocks the pod creation, and here's the details. You cannot run as root because your container is not selected to be exempted from this particular check, right? Just in case you're curious of how, if actual PSA works at restricted level, let's do this. Let's create another namespace, and let's label the namespace to have the PSA check enabled at restricted level. And let's create that same bad pod, right? No, let's create that same good pod, which is allowed previously. So here I'm applying the root pod exempted, which is allowed previously in the baseline namespace, and now in the restricted namespace, it is blocked by the PSA, pod security admission controller, right? So this is how you can make a single or multiple finer grained controls into for a namespace, and you can allow the selected pod to be exempted from the defined controls. And another demo I want to show you is that not only Kyverno applies this check to the pod, but it also applies to the pod controllers. So let's say if I'm going to create the deployment, which violates the restricted check, because I have run as non-root set to false. So obviously, if you have PSA enabled, you're gonna dig deep into the replica set, the pods, and to figure out why the pod isn't scheduled to the cluster. But with Kyverno, if you apply this deployment manifest to the cluster, you'll see that response immediately returned back from the kubectl command, and to tell you that, okay, your deployment doesn't comply with this track. You have to go and either amend your settings, or you have to configure the Kyverno policy to exempt this particular containers or pods. So yeah, that's basically how it works, how the integration works with pod security admission. And I'm curious to see if there's any questions or any doubts. I'd be happy to answer those.
Yes, that's super cool demo. I love those wonderful demo because I want to see like how Kyverno work with the PSA admission. But I feel like PSA is one of
Oh,
the major
there's
yes, for the PSA, like one of the major challenges I see that it's only work with the pod, and the Kyverno work with the any Kubernetes resource. So moving forward, what would be the workflow? On which like one of the use cases I can see how and Kyverno worked together, and also the other question on top of that they are only namespace scoped PSA. They are designed for the namespace. And what about cluster level? And for the cluster level, we can use Kyverno. So I can see that we can use it interchangeably because people are arguing that the PSA is already exist into the Kubernetes, and we don't need to install anything else. In case of the Kyverno, you need to install something, and you need install policies, and those policies exist in the libraries as well. So what do you think, what going to be the workflow is happening moving forward?
Yeah, so I can help answer that, and shooting, feel free to jump in with details, right? So certainly, wherever possible, our kind of recommendation is to enable PSA at least to baseline, right? Because it's built in, it's part of the API server, it's integrated, and you should use it. The problem becomes when two problems, right? One is, first of all, if you're using a managed Kubernetes engine today, they might not have a way to enable that. So Kyverno, the feature that Shooting just showed, it's actually using the same Kubernetes library that PSA uses, right? So I don't know if that we didn't mention that, but the way we have integrated it, because Kyverno is designed for Kubernetes, we can leverage Kubernetes internals, and Kyverno is doing that to apply pod security admission checks, even if you haven't enabled pod security admission in your managed control plane, like on EKS, AKS, GKE, which is not supported yet, right? So you can immediately start trying out PSA on those systems. The second thing with that is, if you enable, like you mentioned, pod security admission at the namespace level, very often, you might say, yeah, I want, to restrict things as much as possible, but I have this one image which has to have a particular capability or needs to run as root for some reason, and I want to just allow that, right? So to do that, that's why we've introduced this new policy that Shooting just demoed, which integrates again with PSA and can apply pod security admission at different levels, but also can allow fine-grained exceptions. So you can say only for this image allow root user, or allow a specific capability, or allow a different seccomp profile, but only for one image within that namespace, not for others. Now, keep in mind that by itself is not secure, because, like I mentioned, that if you give somebody permission to run a workload in a namespace, they do get access to all of the secrets, all of the service accounts, everything else in that namespace. So you still need other Kyverno policies, like you said, to restrict those, right? So there are best practice policies which say, okay, only one pod should have access maybe to a service account token, right? Things like that. So those security best practices are still required. But if you use that in combination with pod security admission, you get the best of both. So the philosophy here is to kind of embrace pod security admission, use that, but then provide fine grained controls where needed, which you can apply with Kyverno as well.
Yes, absolutely. That's super important information because, as you mentioned, like in the namespace and on that namespace, anybody can use that namespace. Anybody can use that namespace to do something else, and you have to restrict that namespace. And for that restriction of namespace, you guys use other policy engine like Kubernetes to align those areas to have more fine-grained controls over it. Absolutely. And like I think right now, a lot of the people having a question in mind, like during the like PSP is removed, is not available from the 20.1.25, and
Right.
PSA is replacing that. So do we have a migration, any migration guide? I see in the Kubernetes doc, we have the migration guide. But if somebody is using and wanted to migrate into the PSA, what
Mhm.
your thoughts, what you suggest to those people? Because that's a very critical topic. Like, do people need, like they think about, do we just need, as you mentioned, like you need Kyverno for the other restriction and more policy grained, because PSA not giving you everything else. Like we talk about cosine for the signing images,
Right.
and we talk about build information to extract the build information to replace a new base image, and when you find this base image cannot be deployed. So what actually you tell people who are listening to watching to us, because that's a really critical topic for people who are migrating to the PSA.
Right. Yeah, so certainly, Kubernetes security pods are again like the basic unit, but they're not everything, right? There's so many other configurations, like you're mentioning, to secure, whether it's the deployments, service accounts, secrets, even things like, at the service mesh level, if you're running things like Istio. So the list goes on and on, right? But you have to start with pod security because that's the fundamental. And there are folks in the Kyverno community, and I'll share the link in the chat. There's who have kind of talked about migrating from PSP to Kyverno policies, and there are guides. There's actually somebody wrote a very detailed way of migrating from PSP to both Gatekeeper, as well as Kyverno or other policy engines as required, right? So there's no tool today, I believe, that automatically converts these, but it takes a little bit of effort. But it's fairly simple, like we were looking at with the policy to what we have done. So previously, before this feature in 1.8, you needed for each control in the pod security standards, you had to install a separate policy. Now, with a single policy, you can manage pod security across your entire cluster and just provide fine grained exceptions, within the single policy, right? So with 1.8 Kyverno, this has become a lot simpler to manage. You don't have to manage separate policies. You can still do that if needed, but the recommendation would be to just have this single pod security admission policy. By the way, one interesting thing is even though pod security admission is enabled by default now in 1.25, if you want to use the latest Kyverno with older versions of Kubernetes, you can, and you'll still be able to use pod security admission because Kyverno integrates the same library, right? So you can try it out even on your existing clusters today.
And one of the comments is shout out to shooting for her great contribution to Kyverno. And we all thankful for the shooting for day one of doing wonderful maintenance of that project as well. And also I'm going to the shooting now because that's the question I frequently ask about it. Because company want to have their own policies to see in the Kyverno. So can you give us a guideline? Let's say the company A wanted to add more policies in the Kyverno library. Where should they go and start contributing or adding new policies into the Kyverno library?
Yeah, we'd love to see. By the way, before that, I wouldn't take all the credits. This project, me and I'm collaborating with one of the LFX mentees. So he contributed this new feature, and we just merged it to Kyverno Min branch today. And yeah, shout out to him, Hugh Kim. So to answer your question, if anyone is interested in contributing to Kyverno or sharing their policies with the broader community, you're welcome to join either the Kyverno Slack channel. We can help put your policies in our sample library, or you can directly open up a PR in Kyverno policies repo. All the samples are managed there, so that everybody else can refer to different examples.
Yes, and one more question adding to the contribution side. Like we see in the LFX mentee program with the Kyverno, there are so many areas. I think it's the application is right now closed. So what are the different areas you see, like people talking about? Where I need a more attention to start contributing to it? Because Kyverno has so many moving spot into it. So can you tell people or students who are contributors or watching this live stream, what are the key area or the first good issues to contribute at?
Well, that's a good question. So mostly for the LFX projects for Kyverno, by the way, we have 5 projects, I believe, for this fall term. And so those are most related to the code development and contributions. So one must be familiar with Kubernetes as well as Golang in order to contribute a feature to Kyverno. But if for someone who's just got started on all the cncf or cloud native area and they're willing to learn more and explore in this area, you can always browse the good first issue. There are plenty of issues logged in Kyverno repo as well as at the website policies. You can help in all aspects, not necessarily contributing to the code base, right? You can help us improve the documentation, how to set up the dev in your local environments, just or even fix a typo. That kind of contribution are always welcome to make and submit it.
Yes, absolutely. And fine, like I'm sharing the link here because we have done if absolutely new people watching about haven't heard about Kyverno before and wanted to learn what Kyverno is. We have done a session on Cloud Native Islamabad with the same gym and shooting, so you can watch that as well. And also, I'm going to the gym because one thing I really notice is about there is a lot of momentum and moving shift going on around the Kubernetes multi-tenancy working group. And can you tell like what are how the Kyverno help people with setting up multi-tenant Kubernetes cluster? Because I see this question raised a lot.
Right. Yeah. So multi-tenancy is, of course, one of the, like you mentioned, if you're using Kubernetes and Kubernetes as its guts as a bin packing scheduler, you want to kind of leverage, namespace based, multi-tenancy at some level, right? So it could be you might be sharing a cluster within your enterprise with different teams, or maybe you're sharing, also in some cases, you're running a SaaS service and you want multiple instances of that application, right? So Kyverno has the capability, like so far we were looking at the validation rules and the validate policies, but Kyverno has a lot of capabilities also for generating and mutating different kinds of resources within the cluster, right? So just one, we can kind of do a quick demo where if you want to be able to do things like whenever a new namespace is created, perhaps what you want to do is to set up all the secure defaults for that particular namespace itself, right? So let's take a look at some policies for that, and I'll go into this multi-tenancy policy set. And if we we'll first just look at the policies, and then I'll apply them and show you how this works in practice, right? So here, what some of the policies that we have are, for example, for every particular, namespace, maybe we want to, let me make this a little bit bigger so we can see it. Maybe we want to control this and say each namespace will have to have some labels, right? And then what we also want to do is we want to make sure that for each namespace, based on the labels, we are able to generate some default quotas. We add a network policy, we add things like limit range, and then we add like finer grained access controls and things like that as well, right? So now, obviously, a lot of different things you could set, a lot of things you can specify on that. But how would this work in practice, and how do you kind of restrict some of these policies to certain users, right? So here I have two users that we will just use for a quick demo, and then we can show, how this works. So let me check if I have any policies here. We'll delete this and we'll start with, kind of no policies. So right now I have Kyverno running, but I have no policies, right? So I'm gonna apply all of my policies here from this particular folder. So we'll just say apply minus F, and we'll do. Um, so actually, let me add the roles first. So I added the roles, and then we'll just kind of go ahead and apply all the other policies as well, right? So now if we do kubectl get namespace, or let's do get cpol for policies, we see we have all of those policies, and they will very Kyverno takes, once it kind of caches them, they will be ready to kind of based on the action enforce and use, right? So now at this point, if I kind of try to create let's say a namespace as an admin, so going back to this policy, as an admin I can do whatever I want, right? But if I try to create this as a special, as a other user, and say I want to create a namespace, it shouldn't allow me to create a namespace without the right labels, things like that, right? So let's create a namespace test, and I'm just going to do this as this user Ned. And Kyverno is saying, hey, you can't do that. Every namespace has to have this particular label. So let's go and kind of see how we can apply that label. So here in this resources folder, we have a namespace. It has a label which has, complies with the policy we set, right? So now if I do, let's say, kubectl, eh, and we'll do apply from the resources folder. So let's go into resources, and I want to apply this, let's say, as this other user as Nancy, that um, yeah, so oh, it says cannot. So I know why this is, because apply actually does a list first. So you have to do create minus F, right? So this is just the way kubectl works. So now if we did the create, Nancy was able to create that particular user, and that succeeded. But if I try to now even do, let's say if I do get namespace test, and I do as Ned, the other user, Ned should not be allowed to see that namespace, right? Because it was created only by Nancy. Now, if we do by Nancy, we should be able to see that particular namespace, because Kyverno automatically set up all the fine-grained roles for these users in that environment, right? Also, if we look at this namespace, so if we do, let's say, we'll do -n, and let's do get quota. Um, or I think we can do describe quota, right? So this, we do something wrong here. We're saying describe quota in -n test, or actually let's look at it because this is a resource which is not allowed by the namespace admin. We'll just do this as the cluster admin to make sure that the quota and everything is set up as we expect for that namespace, right? So in this case, what happened was the namespace admin is not allowed to see that, but the cluster admin is. But if you do something like, get network policy, I believe the network policy is allowed. So we'll make sure that it's there. And if we do as Nancy, we should be able to also see that, or it's actually in this case, it's even preventing that from being, seen by the namespace admin, right? But if you can, you're as the namespace admin, you can run, you can do things like get pods, get applications, see that, within that particular namespace based on how you, set up your permissions and what you allow, right? So that's how you can kind of do, multi-tenancy with a few set of policies in Kyverno itself and control like different resources, especially the important things like network policies, limit ranges, quotas for those particular users. And it still allows self-service namespaces, so it's pretty flexible from that perspective. And you can, but with the right fine-grained access controls that you would require.
Yes, that's super important information for us. I think for at least for me, and I hope everybody watching to us, because this is really a challenge. Because I created a namespace and somebody installed something new on that namespace, let's say Argo CD, but he hasn't allowed to install anything else, third-party libraries on my namespace, but he's mistakenly installed those, and I have no way to restrict him. But with Kyverno, I can restrict those. So that's super important because these are the challenges that relate to day two Kubernetes, not day one. Day one, you just install the Kubernetes cluster and you're happy, your job done. But day two is you are adding more resources in the Kubernetes. And in some namespaces, you won't allow to add more stuff because of the company's policies, because of the cluster admin policies, and Kyverno let you do those. So I think it's a wonderful way of telling people like these are the things you can do with the Kyverno as well. And like on the top of like we can see in the like the multi-tenancy, all these kind of stuff. Like let's see if in the namespace I wouldn't allow to install Argo CD or Flux CD or any like third-party library, particularly third-party libraries, because there's some of the scenarios. So are those policies are available or in the roadmap currently? Like you,
To restrict certain types of workloads, yeah, you can certainly do that, right? So that's fairly straightforward in Kyverno. You can control what somebody, which pods are allowed, which images are allowed. All of that can be managed through validation checks and rules. You can prevent that.
yes, and on the topic of cloud provider like AKS, GKS, GKE, like all the managed services, like I think this is the more challenges for those people who are managing the managed Kubernetes in the cloud,
Right.
and they need to stood up multi-tenancy. So what are the things? What are the things that we can achieve in the managed Kubernetes offering by using the Kyverno as a multi-tenant policy or something else?
Right. Yeah, so certainly for multi-tenancy, but also for pod security, which, as we were talking about before, Kubernetes is not secure by default, even if you're using a managed, Kubernetes service. So you do need to run something for pod security, and you need to also do workload best practices, workload security. So there's almost like 200, community like sample policies in our library now, And there's also some efforts, in the community to create a set of EKS best practice policies using Kyverno, right? So definitely that continues to grow. The other thing you would want to do, so once you have established the baseline security best practices, we recommend, of course, like if you're sharing clusters, even if you're not sharing clusters, every cluster will have, some level of shared services, right? So like you mentioned, you might have Flux, you might have Argo CD, or you might have, things like Prometheus, etc., running in the cluster, and then you have your applications. So it's extremely important to, secure those application namespaces and not give access to somebody to the entire cluster, because then they can remove those security tools, the monitoring tools, and you lose visibility into your cluster, right? So even for a single team cluster, it's important to set up some level of tenancy, right? Because you want to make sure that they are only able to run applications in their namespace and not, kind of do something in a system namespace. Things like that, Kyverno is designed to make it very simple. And you can start with a set of policies, which just mandates that.
Yes, and before I let you go, because I forget this question and it's now pop up in my mind, is we have because Kyverno policy because Kyverno writes audit result to a standard Kubernetes custom resource called policy report, and
Yes.
we have a policy reporter is also available. You can see the policy report visually, what are the warning or audits, everything else. So tell us about, because that's really critical, because all the other policy engines, I think, lacking these policy of the visual dashboard. So what the policy reporter is, and what is the current phase of development in the policy reporter.
Shooting, you want to handle that?
Yeah. So as Sam mentioned, thanks for brought that up. So we have this policy reporter project, which is contributed and work managed by one of the contributor, Frank, and he donated the policy reporter to the Kyverno community. It collects all the policy reports that are generated by Kyverno, and send those policy results to the configured targets. And you can also install the policy reporter UI with the core application just to visualize your policy reports, and you're able to to do the filtering and selections on different levels of like reports. So they have warning, they have failure, success, so all different types of events for the policy reporter. And this is really easy to configure. If I think we still have time, I can quickly share my screen and show you how you can install that in your cluster. So let
Yes,
me
absolutely,
quickly,
absolutely.
yep. So I shared the link to the policy reporter documentation. And here at the installation, on the installation page, there are three sections, right? You install the core applications, and you can also install the core application plus the policy reporter UI, as well as the Kyverno plugin, right? And you can also configure it to be working with Prometheus or some other monitoring tools, right? So I'm going to quickly show you how to install the Policy Reporter application, and how to bring up the local UI in your for your cluster, right? So let me quickly install. So here's the command. We're gonna do install the Policy Reporter core application and the UI via the single ham command. So as you can see here, I do ham install Policy Reporter. I have the UI enabled, and suddenly it creates a namespace called, let's see, get namespace Policy Reporter, and it installs two pods in this namespace. Oops. So let's do kubectl -n Policy Reporter and get pods. Right, so you have two pods running now. And so since I installed the local UI as well, we're able to see the reports via the local UI. So let me see if I have any policy result and policy report in this cluster. While they're empty, let me try to install some policy apply policies. Okay, and let's check the policy report again. Get policy report dash a, oops, get policy report. Okay, so now we can see we have some reports showed in different namespace, right? And then if I'm gonna enable kubectl port forward, so will be able to access that UI locally. This is the command. Since I'm running on a remote server, has the that has the public IP, so we can do kubectl port forward, and you give the address that you want to forward it to as well as the port, and then you would be able to access the UI via access the policy report via the UI, and you will see the details of those policy report. So this is the overall dashboard. You have the name policy report show for namespace local, path storage, policy reporter, and more. And then you can click on those and expand it to see the details of each policy reporter, policy results. Right, so this is a simple way that you can visualize all the results and have them categorized and grouped into different, uh, isolated groups. And then you can also configure them to send the policy report based on different warning, like operations and events to the different targets like Loki, Elasticsearch, Slack, or even email. So there are a bunch of new things added to the policy reporter. And I believe there is an incoming talk that will be present by the policy reporter author, Frank, next week. So be sure to follow us, and we'll, share all the details for the policy reporter uh, in the upcoming days.
Thank you. That's a super, super important and uh, highly informative demo of the policy reporter. And that credit to the Frank for working on this for a very long time. I've done a podcast with him as well, and hope to have him back on the show as well because he's doing wonderful work for the community in the policy reporter side. So before I let you go, Jim and shooting, any talks on Kyverno on KubeCon? That's right.
Yeah, quite a few. So in Detroit, I think we have almost like about six different sessions on Kyverno and policy management between some of us and community members. So pretty excited about that. There'll also some talks on GitHub Con and Security Con, and we have some submissions pending for Sigstore Con. So certainly lots of different things to cover. Yeah, one other quick thing I just want to quickly mention in 1.8 Kyverno, we also have a new feature for signing and verifying YAML files, which is extremely powerful. And this was also a community contribution from a team at IBM. So Rico and Yuji built and developed that feature. It's in collaboration with Sigstore. Very excited about that because it enables a lot of different important workflows like approvals or tamper detection for certain resources for YAML manifest, right? We talk a lot about container image signing, but in Kubernetes, there's two things you deploy: YAMLs and container images. Now Kyverno can secure both.
Wonderful. That's a great news for me. So, do you have like, do you have any demo? Do you have some link we can show to the people, or is it coming ahead in the few days?
Yeah, I mean, we can kind of take a quick look at what this looks like. I know we just have a minute left and the time,
No, no.
but
Yes, absolutely.
I'll show you, what this policy looks like. It's very simple. So here's a policy, which enables, for checks for YAML signatures. And this is a public key that I have configured in the policy. And for things like cluster roles, right? So maybe you don't want somebody to install or manage cluster roles. unless they have been signed. So just like here, if I now try to create this cluster role, Kyverno is going to block it and say you can't do that because it hasn't been signed, right? But let's say if I now, if I want to go ahead and let's sign this a cluster role. So let's do, with this, I'm going to create a signed cluster role. And once that's done, over here, if you notice now I have a cluster role YAML signed. Let's try to apply that, and what we'll see is that should be allowed because it's signed, right? So now I was able to create a cluster role with that signature. One other quick thing, if I go back to that, same role that I just applied, and let's say I want to change it, right? So I want to kind of get access to my cluster. So instead of binding to, edit, I did a binding to cluster admin, right? Now, if I try that same thing again, it says, hey, you can't do that because, well, actually, let's delete the other role first. So we'll just say cluster delete minus F and the cluster role.yaml. And we'll try to apply this. So notice here it's saying, hey, you cannot change edit to admin in this signed YAML, right? So it also prevents that from happening, which is super cool because now you can, sign these YAMLs in your CI/CD pipeline and prevent, tampering for some critical resources in your clusters itself. So great contribution by the IBM team, and thank you, Rico and Yuji, for applying that to Kyverno.
Yes, absolutely, absolutely. And today we have so much wonderful news about Kyverno, and that one is special for me because we already have a container signing verification and these kind of cosign supports available in the Kyverno, so you can restrict only the sign images are allowed to run in the Kubernetes cluster by using the Kyverno policy. And having those YAMLs, the signed YAML file is added another step because this gives you then extra protection because you are not putting any malicious activity into your Kubernetes cluster. So
Right.
that is super, super important for everyone. So, and Kai Hassan is saying, is thanks for bringing Kyverno to us. Really happy. I didn't have to put in effort to learn Rago for Opa. Thanks, Kai,
Right.
for your kind comment. So let me just quickly share all the wonderful resources with you. So here's a guide for you to migrate from the policy PSP to the PSA. And here's the Kubernetes 1.25 where you can see the PSP is deprecating. And we have a Kyverno link, kyverno.io to learn about Kyverno. Here's a GitHub repository to see what the Kyverno is heading up to. And we have a wonderful webinar, the Cloud Native Islamabad, of if you are really new to the Kyverno, securing automating Kubernetes with Kyverno. And we have another wonderful, I think this is a good blog post to read because mentioned during the conversation, Kubernetes 1.25 pod security admission controller is stable. And we have a Kyverno policy reporter. We have to go check that out. And one a good article I read today is examining pod security admission. And I think his web is a very wonderful article to read about it. And one of the best article for me for the I think for the couple of 2 months is securing container-based imaging using Kyverno policy by developer guy. It's been a very, very informative guide to tell you about how you can restrict pod to have to build. You can extract build information from these build images artifact and then tell Kyverno to not restrict those some kind of pods to not being deployed in the Kubernetes. So that's super useful. It's been I think it's been on the Nirmata website. Go check that out as well. And using the admission controller, another one from the developer guy. So these are the resources for you to check out before this session. And we will continue our journey of learning Kyverno with Jim and Jim and shooting in the moving forward as well. And thank you very much for all the wonderful in comments and you have hang out with us and learned Kyverno today. Stay safe, stay healthy. Bye bye, everyone. We hope to meet you again in the future.